we're going to be doing section 4.6, properties of isosceles, equilateral, and right triangles. Please get out your note sheets for this. We're going to start off with some paper folding. So I want you to get out the last page in your notes, and there's an isosceles triangle on it. And I want you to cut it out. Pause the video and come back when you're done cutting it out. When you're done cutting it out, I want you to fold it like it shows here in the picture. I want you to notice that once you fold it, it folds exactly in half and right on top of itself, showing that this angle and this angle, once it's folded, fold right on top of each other and they are equal angles. So what I want you to do now is I want you to take that triangle, I want you to glue it down to the paper that's the 4.6 notes and come right back. Now that you have folded it, I want you to mark on it that they are congruent here. I hope you also noted that since it was isosceles, these sides were congruent. Okay, please mark that also. This means that the angle A and angle B, you just marked that, and you already glued that into your notes. Okay, we're gonna write some notes on top of it. You have a theorem, and you can get out your note sheets if you need to. It's called the base angle theorem. And it states that if two sides of a triangle are congruent, then the angles opposite them are congruent. I'm going to have you do yourself a favor. Write this down on it, the base angle theorem. I want you to notice that if these two sides are congruent, over here, the opposite angles are congruent also. We are not saying anything about the top angle. We're saying the base ones, the ones that are opposite those sides, are also congruent. I also want you to notice that we just said that we have the base angle theorem and we're starting off with sides. If two sides are congruent, then the angles are congruent. We're starting off with sides and going to angles. The reason that's important is because we're going to be doing next the converse of this. And the converse of the base angle theorem states it backwards. It's going to say that if the angles are congruent, then the sides naturally are congruent. You need to make sure you know which is which. The original base angle theorem says if the sides are congruent, then the angles. Converse is the other way around. You will need to write these in your Postlet book and keep track of them, because remember, in homework, there are times when you have to write the theorem that justifies your answer. So make sure you know which one to use. Back when we were doing assignment 4.2, number 28, we talked about equilateral triangles. We're going to have a theorem about that today. We have a triangle is equilateral if and only if it is equiangular. I'm signifying here this if and only if means that we have two things that happen with that if and only if. It means both of these. It means that if a triangle is equilateral, then it's equiangular. It also means the converse. If a triangle is equiangular, it's equilateral. So that means that these three sides are congruent. And these three angles are congruent. Equilateral and equiangular are the same kind of triangle. Make sure you draw something about that in your notes. We have one more shortcut for proving triangles congruent. You need to find those note sheets we did last week so you can write the last one in. Let's do it now. What kind of triangles are these right here? Are they straight, are they obtuse, acute, or right? They are right triangles. For this last one, we must have a right triangle. This is the hypotenuse leg convergence theorem. The hypotenuse leg says that if we have a hypotenuse and a leg, then we have congruent triangles. Here we go. Let's read it. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two triangles are congruent. I'm going to point out that we have a right triangle here, a right triangle. We have a hypotenuse, a leg, and a right triangle. You have to have all three of those things to be true to be able to be congruent. Let's review what a hypotenuse and a leg is. The hypotenuse is the angle that's opposite the right angle. That's the hypotenuse. And the legs are any of the other ones. So if I had a leg here that's congruent to this leg here, then we would have, since we have a hypotenuse and we have a leg of a right triangle, then we have congruent triangles. And that's why these two triangles are congruent. Make sure you draw these in your note sheets. You have another place for your notes over here. Please put those in there. You might have to actually redraw some of the triangles because make sure they're right triangles. All right, we're going to do some examples. We're going to do numbers 1, 3, 5, 7, 9, 10, 12, 14, and 16. So get out your assignment sheets, so let's get started on that. Number one, the instructions say, find the value of x and state the theorem or postulate that justifies your initial equation. So we just had some theorems here that said that if I have a base angles congruent, then I automatically have the opposite sides congruent. So that would mean x equals 8 because those base angles are congruent. I need you to look at your note sheets or your term sheets or your postulate book, whichever they are for you, and decide if this is the base angle theorem for sure, but is it the converse or just the original? I hope that you noticed that when we started off with the angles and went to the sides, this was the converse. This is the converse of the base angle theorem. This is the converse to the base angle theorem. Okay? All right, let's go to number 3. All right. Again, we're going to find the value of x, and we're going to state the theorem or postulate that justifies our initial condition. Starting off with the base angle is congruent. That means those opposite sides are congruent. So x is 7 for sure. Is this the converse or the original? It's just like number 1. It's the converse of the base angle theorem. All right, let's go on to number 5. All right, now we have equations. We have these base angles, meaning that these are equal. 12 is going to equal x minus 2. Solve that equation, and you need to decide if this is the base angle theorem or the converse to the base angle theorem. Take some time, pause this, and work on that. X equals 14 is your answer, and this was the converse to the base angle theorem. Let's move on to number 7. All right. Now, we have an equilateral triangle. Remember, equiangular is equilateral. We also, though, so we could use that theorem, but we also have kind of like isosceles here, and we have these base angles. So x is 60. You can use two theorems. You could have done the one that says an equilateral triangle, if and only if, and that one. We could use that one. Or we could use the converse to the base angle theorem. Let's go on to number 9. All right, number 9. Be very careful with number 9. All right, are these two equal? Now we have the angles here. We have this side going here, and we go to the opposite. So that one means that this is x. And this is not the converse. This is just the base angle theorem. But how do I find what x is? X, all of these add up to 180. X plus 1 plus 40 equals 180. So really, technically, we have another theorem to consider. The other one to consider is the one that they add up to 180, which is the base angle theorem. Excuse me, not the base angle theorem, the triangle sum theorem. And let's solve it. We have 2x plus 40 equals 180. Pause this and finish it so you don't have to just watch me, because you can do this by yourself. 2x equals 140, divide by 2, and x equals 70. Let's go on now to number 10. This time, again, you need to be very careful, because this x plus 75 is this angle measure. This is not a measure of this is not 2 degrees. This is angle 2, and so they have put that in there. So this really right here is x plus 75. What's congruent though? These two are not congruent. This thing goes to that angle and that angle, so the bottom ones are equal. That means that this one right here is also x plus 75. And this is because of the base angle theorem, not the converse. The base angle says that if two sides are congruent, then the base angles are congruent. So this is the base angle theorem. And my first equation can be written because I have this 50 degrees plus 2 of these. 2 of the x plus 75s. Now, you could have written x plus 75 and x plus 75 if you want. It's going to be the same thing. But there's 2 of them. And that equals 180. And the reason we can write that one is because the triangle sum theorem. Pause this and solve. All right. Check yours with mine. I'm going to subtract 200. I'm I'm going to have 2x equals negative 20. And that will make x equal negative 10. And that's an okay number. We're allowed to have negatives when we're talking about x. Not necessarily sides of triangles, but we're doing fine. Let's move on to number 12. All right, number 12. This says 6x plus 7 equals the same as this measure here. Which of these angles are congruent? Are these two congruent? Well, let's check. We said here that this is equal to that because of the base angle theorem. So that would mean that no, they're not equal to 70. They're both equal to the 6x plus 7. So if you want to just write a 6x plus 7 on each of those instead of the arrows, that's fine also. They just couldn't fit them in there. So we're going to add all those up to 180. So this is the base angle theorem. And the triangle sum theorem. And that states that all those add up to be 180. So let's make an equation. We have 2 of the 6x plus 7s plus 70 equals 180. Go ahead and pause it and solve this. Come back and check it. X equals 8. All right, let's move on to the next one. And the next one is going to be number 16. All right, now, this one says that we need to state the additional information that's required in order to know that the triangles are congruent for the reason hypotenuse leg. So remember, we had to have 3 things for hypotenuse leg. We had to have a right triangle, we had to have hypotenuse, and we had to have a leg. So we know right now that this is congruent to itself, and that the question to ask, is that a hypotenuse or is that a leg? So the hypotenuse is the one opposite the right angle. That is the hypotenuse. So that's the leg, and we need then the hypotenuse, the hypoteni in this case. So we need those. So we need ZY to be congruent. Now we have to list this in the right order. ZY, and we have JX here. Those two have to be congruent for hypotenuse leg to work. We are done with the examples. Let's review what we did. We just talked about isosceles triangles and their congruent base angles. We had, if the base angle is congruent, then the sides are congruent. And we had, if the sides are congruent, then the angles are congruent. We had equilateral triangles being equiangular and vice versa. And we had a new shortcut. We had the hypotenuse leg shortcut. That stated that if I had a hypotenuse is congruent and a leg of a right triangle on both of them, then they are congruent to each other. We are now done. I hope this has been helpful. Have a good day.